Hello, hello, and welcome to this video. So, in this video, we will start the discussion on lifetimes, and probably it will last one or two more videos. So, a total of two or three videos will be required to cover lifetimes fully. So, lifetimes are probably one of the most confusing concepts in Rust, along with Boro checker. Borrowing is quite simple actually. If you follow the simple rule that there can be one mutable borrow and at most, and there can be as many as you want, immutable borrows you can have. Lifetimes are slightly more complicated. In lifetimes, you have to know how long a variable is going to live. This becomes particularly interesting when you deal with multi-threaded programming, when you pass around values and variables, particularly when your threads take lock and all that, it becomes quite involving that when a lifetime, how long a variable is going to live. Lifetimes involve annotation as such, but you can program a lot without annotations. But there are times when they become mandatory. So we start with a simple program to show how lifetimes work. So suppose we have a variable I is equal to 3. It's a local variable, it will live on stack and it will end before the main function ends. Just before main function ends, this variable will end. Now suppose we borrow here, okay, inside braces. Then the lifetime of borrow is within these braces. As soon as the brace ends, the life of borrow 1 goes out of scope and borrow 1 ends. Similarly, borrow 2 ends as soon as the second lifetime ends. Now let's look at how we can annotate variables. So suppose we declare two values, 4 and 9. Now again, these will be on stack and they will last as long as main lasts. So we take reference and we print the references in a function printRef. Now, if you look at printRef function, X has been given the lifetime of A and Y has been given the lifetime of B. Okay. Now these two lifetime must be both at least as long as the function printRef last. But you see, the variables are going to live even after printRef ends. So there is no problem. But suppose we have a function failed borrow and we mark it with the lifetime A. Now this lifetime A is used to mark the life of X. Okay. Now in this case, what will happen is, if you look at this function, X has been borrowed to Y and Y is marked with lifetime A. Now X is going to end as soon as this function comes to an end. Basically, before the function ends, X is going to end. And the lifetime of function is given to the variable Y. Now what happens here is, the function will outlive this X. So the borrow is going to create trouble here. Okay. The lifetime of borrow is going to create trouble here because Y is going to live longer than X. And a shorter lifetime cannot be given to or cannot be coerced into a longer lifetime. So that is a problem here. Now let's look at something called Ellision. This one. Okay. It is not necessary to annotate the lifetimes. Okay. You can elide it, or in other words, you can omit it. Till now, whatever programs we have written, those were elided programs. Suppose there is a variable X is equal to 3, we have elided input, we pass a reference, and then we print X. And in annotated input, we pass X, and the lifetime of function is A, the lifetime of X is A, and we print the annotated input. And similarly, we can take the references of x and annotated reference of x and return those values x. Now we see this works because x is going to live longer than the functions. Okay, otherwise it won't work. So another one which program which we have is how you can annotate the functions. So for example, here we have two values x and y, 7 and 9. We say print 1. Now print 1 takes one variable and it has lifetime a. And x also has the same lifetime and you can print 1. Note that you cannot give this lifetime to a local variable. It won't work because function is going to outlast the variable. Then we have print multi. We have two lifetimes a and b for x and y, and we print multi. So we print both x and y. Again, a and b are going to last longer than the local variables. So if you use local variables with the same lifetime, it won't work. Then we have pass x. Get is equal to pass x. So we pass x and y, x, and we ignore the second input, and we can return x with the same lifetime. This will work. Okay. Remember that you have to use proper lifetime here, otherwise it will cause trouble. Then we have print 1z. Now print 1z we have already seen. Then we have add 1 to a mutable variable t. So we add to a mutable variable t, we dereference it, and we add 1. Again, the lifetime of the variable is same as function, but function has the same lifetime as x, and x is going to outlive the function. And then we finally print 1, which will be basically 4. So familiarize yourself with syntax, and it is not necessary to actually annotate everything you have in your code. Okay. For example, when we saw Ellision example, you see this will be handled by compiler. When you align this lifetime function, the code will see that what is going on. For example, here you don't need to give lifetimes to this. Okay, this is basically causing trouble here. All right, if you give lifetimes, if you just remove the lifetimes, it will work nicely. Okay, and let me show you by compiling this. This is lifetime 2. So let me increase the font and we say Rust C lifetime 2.rs. So you see it compiles, but if you give it lifetime annotation, it won't work anymore. Okay, so while annotating, you have to be careful that wherever it is demanded that you use a lifetime, you should use a lifetime appropriately. But in general, if you just understand how the variable is going to behave, how long it is going to live, it works very well. It is not necessary to annotate everything with lifetime. In fact, my advice would be is avoid the annotation as long as you can. Okay. There are two reasons for that. One is that the program becomes less readable, okay, with explicit annotations. Second is that you might fall in trouble with annotations. For example, I have shown in the failed borrow. Okay, so it is not necessary to annotate everything, but there will be times, particularly when you are doing multi-threaded programming or you are receiving values from unknown sources. For example, when you write plugins and all that, and you receive values from unknown sources and you don't know how long they are going to live, then it becomes a problem, and there you will need to explicitly annotate the variable. So this is the introduction on lifetimes, and we'll see more examples in the next video. I will end this video here. I hope that you have enjoyed this video and found it useful. Lifetime 2.rs gives this compilation error, as you can see. So I'll see you in the next video with more on lifetimes and more examples so that it becomes clearer that when and how to use lifetimes. If you master borrow checker and lifetimes, then rest is just like any other language. These two concepts are the most complicated ones. Borrow checker, you have to be careful, but it is not very difficult. Sometimes you have to plan ahead that how you are going to satisfy the borrow checker. And lifetimes particularly come in picture when variables from unknown sources where you don't have control over the lifetime of the variables, there will be a problem over there. You have to be clear that how long a stack variable is going to live, how long a box variable is going to live, when to return a box, and how we can use heap allocations to basically when we have to do clone, when we have to reference. So those things you have to take care of when using lifetimes. But it is not very difficult. With practice and more programming with Rust, it will become easier for you to understand. It takes a bit of getting used to, okay, because other languages, if you have programmed in C, C++, then the history which you carry with yourself becomes a baggage. You can't treat borrow checker and lifetime just like another feature. These are different than other programming languages, and we have to be careful around those. So I'll end this video here, and I'll see you in the next video with more on lifetimes. Thanks a lot for watching the video. I'll see you in the next one. Till then, enjoy.